a little bit about myself. My name is Luke, as you already see. So about 7 years ago, I co-founded this company called Electroder, and now grow to be a world-iconic forum global innovator, specializing in enabling battery design and manufacturing. And as I mentioned, I've been for the past 4 years, has been really focused on the European regions, and supporting my customers to be successful in releasing their first cell design and putting together their lines and together to manufacturing hopefully in the right outputs and the right yield. I also sit in a steering committee of Global Battery Alliance Battery Passport, as well as the Security Critical Materials the group. So we're gonna start it. So we get started with some really I think is really frustrated fact, but fact happened in the past 5 years in Europe. But I think it's really important to face reality, but more importantly, for us, everybody that in Europe and in elsewhere, is to dig into why and see how we can do that differently for the next five. So this is a map that I pulled back in 2022 when I first moved to Europe, when the European Union has about 38 projects around the continent in supporting cell manufacturing to be successful in Europe. A lot of them has been focused on gigafactories and starting really high level of capacities. And when I look at this map last year, and I try to, do the analysis of where are those project stays. And I'm very unfortunate that I hate to use the word failed, which, not what I mean to be seeing them as a failure, because, you're gonna start from somewhere and fix and learn and do the better. But if a project has been stopped or not achieving to what is regionally set up, then let's just temporarily call that way. Then actually a lot of them are not in good shape. And that's very unfortunate. We're not standing here to, you know, just calling, the pioneers to be failed, but it's very unfortunate. A lot is not going well. Like I said, this is just to try to analysis the fact and try to dig out why, so that we can provide it lessons learned for the people who continue to carry over the very important initiatives, right? So I and as me, you maybe argue that okay, this is Luke, this is 5 years ago. And if you look into the companies that in SP 500 5 years ago, and then 20% of them are out of SP 500 now. So if you drag it for a longer time, then a lot of the project will fail anyway. So I put the map from the very end of 24, and I try to see, okay, what's going on with the very latest one. If just 12 months or 16 months has passed. And then, yes, there are some that the red lines are crossed. That means that they're no longer that building capacities. Of course, Northvolt has a different story now with Lighten to, acquire them. And then the yellow ones are the ones that really also not achieving what was it supposed to. So again, very unfortunate to be in this situation. So a lot of us in the industry asking, why is it? I mean, there are different perspectives. There's the policies things, there's competition thing, there's supply chain thing, and we each have a different answer. And for what I have been focused on as engineering and technology, um, I have really this interview caught my eyes and trigger a lot of thinking, which I will presenting later. Which is this is Nicholas Tangent, the CEO of Northern Bank Investment, has interviewed Robin Zeng, the CEO of CETL, which is the largest cell manufacturer in the world, and he asked why. When European companies has been failed in scaling up the production, and Robin has given three answers from his mind. Number one is the design was wrong. The second is the process was wrong, and the third is the equipment was wrong. And I have to say that in many perspectives, I really agree with those, with my experience. But I really want to dig into about is, as I said, is why. So because when we know the reason better, then we can help people to fix that. And this chart is what I made based on my experience. And I try to do that in comparison of how cell manufacturers succeed in different regions. And the gold line is representing as competency that needs to be required to success for scaled cell manufacturing. And if you look into the China side, then in China, cell makers has been having a good experiences. They're strong. They have a lot of know-hows and have been there and have done that. And at the same time, the local vendors has been pulling and to catch up with similar level of know-how on their side as well. And when we try to replicate it that in Europe, we really face reality that no matter how well founded the cell manufacturer is in Europe, we're still a startup. And I like that for some, previous capacity has been already been there, right? With you can name it with AES in Sunderland and many other places. A lot of the manufacturing projects we see on the map is a startup, and which means that know-how isn't there as deep as Chinese cell manufacturers or Korean manufacturers. Their lack of experience and also some project they might have pilot scales or lab scale, but putting that in the giga, especially on 20 giga and above, is a whole different story. And then in the meantime, the vendors are also creating a gap that if there's a local EU vendors, then it face similar things that we describe as cell manufacturers. If there is using Asia vendors, then there are other things that creating the gap, which is the language, the culture, and it's working remote. So the gap is getting bigger on both ends, which is, for adding them together, then it's really hard to achieve the competency level to create cell manufacturing. And as I said, I mean, this is just one way to look at it. There are also things that we rethink about policies and support, financial support, and supply chain, other things. I don't deny that those are important. This is purely looking at engineering competency level. I think that is kind of the very critical part that we need to fix to make cell manufacturing successful. So, what I want to discuss with you first is cell design is essential, which why we're even talking about cell design because this is a manufacturing session because um, cell manufacturer have to deal with products that's going to very specific applications. And because we want to achieve the performance of those applications, we need to put together a design that touching the boundary of manufacturing sometimes. And if you look into the history of of cell design, chemistry has continued to evolve. And this chart is describing what has happened from 1990 all the way to almost to today. That chemistry has kept evolving, and even for the same chemistries, has been evolving to different generations and has been evolving with demanding requirements on automotive and ESS. That created the design to be continue to challenge its boundaries, and it could be leading to manufacturing changes and parameters of manufacturing and the equipments that used to be hard. And so there's always going to be innovation on the design to challenge the status quo, the manufacturing. And then you look in the cell formats, which is more on a micro level. And it has also showed a similar pattern of evolution. There are round cells, cylindrical cells, the pouch cells, and then the prismatic cells, and then round cells come back by renovation of Tesla, and then a blade cell was invented somehow as a reformat of prismatic, and prismatic getting bigger, and seems to be every time we figure out assembly line and make it to be a high yield, and then the cell design is asking for more. C-rate is the latest thing that we call the C-rate wall, which leading to faster charging. Is also going higher and higher and requiring the design to be in different than what it was. And so so we all know probably all know that the manufacturing line of cells are built to certain design. It's not like magic that can hold for every design. So when especially for scaled manufacturing lines, when you build it, then it somehow like lock in the boundary of design. So you can only make certain designs in range. So one of the mistakes has been observing in Europe for the past few years is that a lot of the projects goes rush into purchase order of equipment before a solid cell design has been enabled. Means that in many ways, in many times, that when the project's founded, and then it has a very limited time to go rush to equipment wonders, and 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 but the cell design isn't ready, and the equipment manufacturers are actually sometimes help to shape the cell designs, and later lead to rework. And of course, you can imagine the cell design is easier to rework, but not the equipment, right? The process when you change when you receive the equipment is there. So I think in here, I think a cell manufacturer to get a blue cell reference cell is very important. Well, which means that the design may change. It may fit into the process later, but need to have some baseline solid enough before it go out to search for the equipment and the process. And that's very important. Also reflect on the freedom to operate. Means that check on any IP and risk, so that those are the parts I have been seeing that rework happens when the line is already arrived, and when you have the hardware there, trying to adapt to the design change, the cost become really enormous, and sometimes it's not affordable. So that's why the design is very, very important in the early stage, and so that it's not becoming a reason for rework on the line. But later, when you talk, actually the design sometimes shall be changed to adapt to make the manufacturing more friendly. So the second part, the thing that I want to share is manufacturing is very critical, and that seems no brainer. But if we dig into there, is again, this is before we're talking about any equipment. Process planning is very important. I have seen projects that actually putting the equipment manufacturers, the equipment vendors, to be in really bad position because process has been fixed and it kept changing. And the equipment has to be redesigned multiple times in already very demanding time. What we're talking about here is step planning and layout planning and selecting mature process rather than state of art process, so that it will enable the equipment to be in good shape. This is part of the important to scout for the source of supply of good solid equipments, and and from the cell manufacturing standpoint, this is also helpful to their capital investment because when they think about more hardy on this, we could have a plan A and plan B and go sourcing for multiple different suppliers rather than one single suppliers. And because a lot of the process will be tied to who can make that equipment for that process. So this is actually a part that's very worth to invest from a time standpoint, from a resources standpoint. And what I show here is a prismatic cell assembly. It's actually not even including electrode production, which is have several steps in before that. The mixing, the calendar, the mixing, the coating, the calendaring, and the heating part of that. This is everything that after the electrodes are ready and putting them together as the cells. And even one page is not enough. So my point here is not every process is the same. If it's a different design, then all this can be potentially changed, depending on the layouts and the resources of the cell manufacturer. This can change. So there's not something that you can just take one plant, its best blueprint, and to put in the second. Especially when it's across different continents. So whenever we hear that cell manufacturers are trying to build multiple factories the first time, but in across a different continent, a different countries, is really not a good sign. That because the process couldn't be the same. It's really hard to be the same. And last but not least is getting build and continuing improvements. Even when the equipment's ready and we're running FAT, which is at the Wonders factory validation, we will face places that we need to change or we have opportunity to improve to put in that way. And even that we run a successful FAT when we put to the equipment to the customer side, to cell manufacturer side with the SAT, is the on-site validation. We are finding continuing improvement opportunities. When we're ramping up it and commissioning, we find opportunity to improve. When we're running it, we find opportunity to improve. It's really, really important to thinking cell manufacturing process as a process instead of end results. I think the helpful mindset in this way is that you can really take approach of ramping up, which means that the first few trials you're running are setting up good data points, and then you're allowed your team to, failed, but actually it's a success. You're allowed your team to go slow, but actually it's going fast. This is important also going into operation side that we'll continue to find opportunity we can improve speed to produce and improving the yield. And I think there's really not many times that you can achieve to 98% of yield and 99% of yield all the same all the time. It's more of a game of getting to a successful yield and then improve it. And then when you increase output, and probably the yield drop, and then you coming it back when you do cost reduction and you sacrifice some of the yield, and then you find a way to improve. So it's kind of a game they always play. So you have to allow yourself not to be perfect in the beginning, but you always have to challenge the team to getting better every single month. So, and that come to something that I want to share with some real stories, which is how the design and manufacturing to work together. This is where that design design can have a perfect performance. You can have a perfect design to hitting all the KPIs that your design team care about. But then it leading to parameters is really, really hard for the people on the floor, which is hard to manufacture. And in the meantime, you can also have manufacturing parameters, are really achieving how to the production KPIs, but it's not giving the best performance of design, and how we can work together. So instead of talking about theoretical, I would share some best practice, and I'm hiding the projects, and so there's no confidential information here, but also solid enough to encourage best practice sharing and learning. Um, so the number one best practice that is a design need to happen way before equipment, and a list of milestones which including every perspective of design and the DfM and what the manufacturing is needed, and to consider FEMA and failure analysis in design mode will be helping later on. What really on the other side um, is to rush into buying equipment. And that happens in Europe, somehow extended, related, relevant to the funding process. Some of the public fundings that requires that you have to spend it and go after the purchase order in certain times. So, but before you really get the funding, you don't know that, so you cannot start that. And that really created trouble that in some cases, that when the projects receive fundings, then they immediately go look for suppliers, vendors, and then start the purchase order. And I have been seeing projects that asking the equipment supplier to submit a cell design for the cell manufacturers, and also think in a way that when you spend millions and something billions of dollars or euros in that perspective, and you ask for your equipment suppliers, can you do this? Can you do A? Can you do B? Can you do C? It's not uncommon that you got okay, 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 because they want your business, and there are multiple vendors bidding for it, right? So the point here is think through and conduct due diligence on designs before equipments, and control that process. The second part I want to share is about visual detection. Sometimes is underestimated. I the visual detection or is helpful not only just for quality control perspective, but also when we first build a line, that when we first build a cell, it also created data pool that important for us continuous improvements. So when there's no or there's all just like generic visual inspections, it not only means there's bad quantities leading to all the bad things you can relate to safeties and things. It also means that we're losing the opportunity to learn from the very very beginning, and that's in particular bad for projects that firstly building the cells and or any new designs, because the data is very very valuable. Um, the third is we need to encourage a culture of design for manufacturing. Um, I can give a lot of examples that the design can be perfect, but it asks for aero densities that's really really hard for the handler to do or coder to do. It give a very very solid uh, design, but it's hard to crimp. So there's many, no matter you're talking about the fabrication process or assembly process, there are a lot of trouble that the design can give to the manufacturing. Right? So when the cell designers or the R&D team is actually building the products on the paper, they need to put themselves in the shoes of the ones who are actually making it and think whether that's in the boundary or not. This is not a talk about to compromise. This is talking about to think for things that eventually that can be built at target yield rate and target volume. And the least thing we want to happen is the two sides are fighting for their own solo. Is design right? Yes. Is manufacturing right? Yes. But when you put them together, is wrong. This means nothing to both of them. And there are cases that manufacturing can help a great deal to design. I have been seeing manufacturing requirements that really not making so much sense for the products. So in that perspective, I think the other side need to understand only when we have a good solid performance of products, what we make can make sense to compete on the market. And that's easy to say here than in real practice. So I think one of the best way here is to encourage communications and or in and of course I think the design team usually kick in the game earlier and encourage to think about and having some process to check about manufacturing failure analysis even on the paper level is going to help for a lot. Um, the last but not least of the practice I'm going to share is to encourage in-region components. Uh, there is a cost of saving that, for sure. Is the I mean, a lot of the many of the equipments that we're purchasing today comes from Asia, and that's really that's just a fact of how the industry is today. But it doesn't mean that all the components, that must be out of the region. We recently have a project in Europe that I believe have the highest number of European components in the flexible line. That the number of in-region partners are being encouraged to participate in. And of course, there is a cost added to it. There are also a complication on that because a lot of the components are being put together the same, like very first time, and you will be facing the equipment or the general assemblers to say, no, 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 I haven't done that before. I haven't used them before. But if you're building a line, and I think eventually you'll benefit from the service if you feel that components can be sourced closely. So um, I think each of us will have a different situation in here. And what I want to emphasize is we do not have to accept the equipment as it is, because the equipments need to be redesigned, need to be certificated, and so when there's a chance that it can include in-region components, in many situations, it actually can pay off. So I think I'll open the floor for questions, and I'll open the floor for in exchange. I'm also keen to learn from